are important topics. We have in graphs. What is a graph actually? Graph is a collection of nodes and edges containing pairs of nodes. Okay. So what types do we have? We have a directed graph and and an undirected graph. And direction of the edges matters or not. Okay. What do we have? And there are also these two differences, and other two differences are like one can be weighted and other can be unweighted. Edges have weights or not. This means that, okay? And we have other two differences, that is cyclic and acyclic. Okay, that means contains cycle or not. Okay, and we have more differences like connected and disconnected. So it means disconnected or connected. Do you already know what that means? So I'm just gonna erase this. And what do we have for representation? We have like adjacent matrix of 2D array, and we have adjacent list of array of list. Okay, and we have traversals of BFS and DFS. You already know the full forms. This is the binary. First source, and DFS is the first search. This uses a queue and this uses a stack or a recursion, okay? And some of the important algorithms are uh, Green's algorithm, topology sort, and Krukow's algorithm, and yeah, even this is important algorithm, but I have issue with reading this. I can just write it out so people can know. So it's like this. Chipstra, Chipstra's algorithm. Okay, and this is important. This goes like short path, winged graph. Okay, this can be used for that. Okay, I will just try to mention these in description, but let's see. And we even have applications for it, like social networks and maps and dependency graphs and networks. Okay, I'm not gonna write in it. You can just know yourself. Now we have hashing. What's hashing? Hashing is basically mapping data to fixed size. Okay. Um, Hashing, mapping data to fixed size is the definition for it. Which functions? Collision handling, chaining opening ad- addressing. Applications are dictionary, lookup tables, and catching. I don't think so this topic is that important. If you have interest in it, you can look up for it. I didn't know about this much, so maybe gonna do this. We have recursion backtracking. You already know what recursion is if you are seeing this video, because it's just a brief explanation. You must know what is recursion. Recursion and backtracking. Recursion is a function calling itself. Let me write it down and write it for recursion. It's function calling itself. What's back? What's backtracking? Backtracking is try all possibilities and backtracking on failure. Okay, I'll write it down. Possibilities and backtracking on failure. And we have examples like factorials, what is it? AC, and queen, and pseudo, pseudo solver. Okay, recursion and backtracking. Then we have dynamic programming. What's dynamic programming? So let me just see for it. So dynamic programming is IP in a short form that is there. So what is the concept of it? The concept is to solve complex problems. If they have really hard problems, they are really complex, then we break them down into sub problems. Like sorting solutions, okay? What are the types of it? Memorization, memorization. Talk about how one thing is tabular relation. That is important to talk about. Okay, these two are the types. What do they? DP stands for dynamic programming. And this basically has a definition like we have complex problems, we break them down into subproblems or solutions, solving solutions. And types of it are like memorization that goes from top to bottom, and we even have tabulation that goes bottom to up. And what are the examples for it? Examples for it are like Fibonacci problems, and we have Knapsack, knapsack, and we have the longest common subsequence. These are some kind of questions that you can find it on LeetCode and any coding platforms where you can practice these topic-based questions. Okay, these are related to DB that hard to understand complex, we break them down to learn. Okay,